So now it's a pleasure for me to introduce Rafael Ferreira da Silva. The man is from Brazil. I'm from Uruguay. So he knows who plays better football.
Oh, come on.
Yeah. You have this one, and that's like I told you.
Yes.
Sure.
Okay. Let's see if this works. Yep. Can you hear me well? Yep. Just wait for the slides, but what's coming first? Nicholas, thank you for the invitation. It's been an honor. New Zealand has been, on my bucket list for a while, so I'm very excited to be here, be so well welcomed by the multi-core community and also the locals. So I'm very excited about that. I come from Oak Ridge National Lab. As Nicholas said, I'm Brazilian, so I'm a kind of a different Brazilian. So that's why, Nicholas said you have to talk about something, that people wouldn't know. If they Google you, they wouldn't find information. So I was thinking to say, there's a lot of things I can say. Let's try to go get something nice. It's not too weird. And let me get this thing working here. Yeah. So basically, everybody when they talk about Brazil, they think, oh, are you from Rio? Oh, are you from São Paulo? Are the two places that everybody knows. And no, I'm not. I'm from this point here, okay, that it's a small city called João Pessoa. It's small for Brazilian standards, about 1 million people. But the particularity of that, it's the most eastern point in the entire America. So we have a point there that you can go and visit and say, it's where, like, the eastern side of the entire continent. And we make jokes. Yeah. Of course. Yeah. You go there.
Thank you. That's why I
Yeah.
support you.
Yeah. So, there, we make the joke that it's where the sun rises first, because the first place comes in America. We are very close to the equatorial line, so we make a joke, that we only have basically 2 seasons there. That is summer and summer with rain. So, so it's a beautiful city. I see I grow by the beach and, enjoying. It's growing fast. But I just want to take one curiosity. If you Google a little bit about the city, and there you're going to see this movement called the cangaceiros, that it's like from the countryside of my region. And they were like, bandits, basically, in the late 19th and early 20th century. And the leader, that he would call himself Lampião, coincidentally, his entire name has also my surname. So I'm here to say that I have no connection, or maybe I have. You don't know, so be careful. I just make the joke, coincidentally, we got the same family names. And basically in Brazil, you're going to see very often, like, this one comes from your mom, and the second one comes from your dad. So that's, some different combinations end up with the same last name as him. So that's a funny curiosity. But anyway, getting to the topic of this talk, a lot of people, put me on the spot here, like Larry, Sunita, and the others say, oh, Rafael's going to talk about workflows. And then I had a talk when I came here, I had a plan, and then I said, oh, now I need to talk about this now because they're saying I have to talk about it. So, I said, okay, start keeping changing my slides, and I changed up to 5 minutes ago. But Sunita gave me a very nice point because she ended with that, slide to say, oh, I have a Slurm, I'm going to schedule everything else. And I told her, hey, I should take your slide and replace mine because it's basically almost the same thing. And this is where I want to start. This is where we are today with where we talk about autonomous science. What is the next step? We talk about HPC, we talk about edge computing, cloud, quantum, AI, and so on. So what we are keeping seeing more and more today is you have, the computing facility. I come from one right now. I've been just 3 years and a half there. But I learned so much on procurement process for the machines and so on. And, we keep adding, we keep saying, oh, we're going to have AI. AI for HPC, HPC for AI, AI for HPC for AI, or whatever combination you can do. Somehow we're going to have AI there. We get into, quantum. that I've been talking more and more often. So how are we going to be working with quantum inside the system? But now, as Sunita just had on her almost last slide, we're not talking about just one computing facility anymore. It's how we connect everything at this point. So we might have, we need to consider other facilities. And like me coming from DOE, I'm talking about experimental facilities, observational facilities, so and other computing facilities. So how we connect all of that? We have different instruments. We have edge resources. We have cloud, that we are connecting all of these things together. So we need to be looking, we have all of this today. We have a bunch of solutions. We do a lot. But unfortunately, a lot of it is manual. So the dream would be, and of course I had to have a ChatGPT generated image. If not, it wouldn't be like a cool presentation. So the dream is how we get this to be automated, how we look into smart labs, labs of the futures, autonomous science, whatever name you want to give, because different people give different names, or autonomous discovery. I think this is a new one I heard. How we know that we are connecting different labs, different resources, and enable these in an autonomous way. When I say autonomous way, it's not just use workflows to connect, it's also how we can leverage new knowledge. So, for example, when you're doing, for let's say, material science lab, and someone has a biology lab, how a biologist might help a material scientist, with their scientific method, not only with their resources, but the knowledge they have or some data they produced. Something that came to me when I heard about, the Karen's talk about digital twins, say a digital twin, might be another part of these labs that we connect, that we produce new data. So how we can leverage this kind of information, or even if you take a field, an agricultural field, the entire field could be another lab, that we might plug into this kind of ecosystem. So that's the dream. There's a lot to do. And today, especially with HPC, AI, ML, quantum, and more and more things coming cool, we would love to have some kind of autonomous operation, near real-time response. And I keep reminding, near real-time, not real-time, because it's still hard to do it, depending on the definition you have. And we need, to start putting like big words like standards. Oh yeah, it's so easy to talk about standards. Nobody wants to do them. Okay, it's just a nightmare. You can spend years talking about it. Dynamic resource management, so we can manage this kind of different workflows. So in this talk, I want to try to talk a little bit about different efforts we have been doing. So recently, in November last year, we organized a workshop called Shaping the Future of Self-Driving Autonomous Laboratories Workshop, whatever. The idea was bring, people from different domains to talk about how we can connect the actual labs. In this case, was very focused into material science labs with HPC, and have the data connecting all of that. And the idea of this workshop was about 40 people. We discussed, came up, there is a report there is a link, so you can access it. We have a bunch of recommendations. One of the main recommendations is create a consortium, so we are taking the steps around that. But interesting things come around and say, well, a lot of people start to thinking about smart labs as when you would ask, oh, what is a smart lab for you? Or how you connect the different smart labs. And people say, oh, yeah, I'm going to add AI to my lab, and I'm done. Well, this might be doing some intelligence or some automation into your specific lab, but how you can share knowledge between different labs to make this connection. And this comes a lot of also the vendor side, because when you have these instruments, they normally have proprietary software. So how you can create standards that they can share the data in a way that you can manipulate the instruments, that you can understand what the instruments are generating and so on. So that is one effort that we started. So on this talk, I'm going to start from the high level that we get to the dream, and then we start saying things that we did to get to what I do, that is workflows at the end. Of course, I come from DOE. DOE is also looking into this problem. And here I'm exaggerating my role at DOE to say that I'm taking one DOE program and moving to another level, that is this autonomous science, how we can leverage that. So DOE has a bunch of different facilities. And there is a program called IRI. I don't know if you heard about, but Kevin mentioned that during his talk or question. So IRI stands for Integrated Research Infrastructure. So IRI wasn't looking at all the aspects of the automation science, automation discovery, but it started to say, hey, we have a bunch of facilities, and it's a nightmare to, you have your code running at NERSC, you want to move to OLCF or you want to move to ALCF, and it's a nightmare because the software stack is different, no policies are different, and we can't make these things work. We have Sunita had a nice figure about the D3D, the tokamak instrument. There are things running there. They do a lot of work to connect to one facility, but if they want to run in another facility, then it's a completely entire new process. And it's going to take months or years to get things done. So it's not efficient. So what DOE is trying to do with that is say, well, let's work together and solve all these issues, and everybody's going to be connected. Of course, if we sit, and take a lot of people here, all the smart people here, we sit and say, do we have the technology to do that? Yes, we can do this. It's not hard to do. What is the main problem to realize that? People, policies, different agreements, levels, security, and so on. So I've been a lot involved on that. So I'm I'm part of the IRA leadership group. I represent OLCF with my supervisor. And each institution, so each of the computing facilities, so NERSC, ALCF, OLCF, it's connecting with ESNet, that it's providing all the connection on the network. And if you didn't hear about, there is a new project that is trying to create an HPDF, that is a high performance data facility. So it'll be the fifth computational facility into ASCR at DOE. So while these ones are these two, leadership computing, capability computing, networking, HPDF is going to take care of data creation processes, storing, doing data preprocessing, and so on. So one of the things identified during IRI is saying, well, we need to start thinking about these cross-facility workflows. That they changed the name again. Now it's multi-facility workflows. There is a bunch of names to say the same thing. So they identified 3 different patterns, and one is time-sensitive pattern. So think about near real-time processing. So streaming, data streaming, how we make these connections, and we have to accelerate the science there. Data integration intensive, so basically everything that is doing data processing, multimodal data, and so on goes into that category. And the long-term campaigns that are the regular still mod teams that you have that is going to run for long terms on these systems. Of course, they came up with different practice areas. There is a report about that. If you go to the IRI website, you can get all this information, get the report there. But I wanted to emphasize that right now, IRI it's a program at DOE, but we don't have any money. So we are running on facility money, because on facility we are already funded, so we can reallocate our resources to do that. And we have a leadership group. We have an outreach and the communications group that I co-lead with Eli Dart from ESNet. And there are 2 other technical subcommittees. So one is called Trusted, that the idea is to discuss federated authentication, because we at OLCF, we don't trust something that was generated in another facility. So how we do that? And there is an interfaces committee that is very related to what Larry was saying about creating this common interface. So they are trying to create a specification of an interface, because they know that each lab is going to have their own implementation, because they have different software stacks, policies, and so on. So at Oak Ridge, so I started try large and trying to go a little bit narrow. So at Oak Ridge, Larry mentioned that there is one initiative called Intersect that start focusing more into how to solve parts of the IRI problem. So the idea there is still actually Intersect is running until the end of this fiscal year, is how you can connect labs that are at the edge and share information across these labs. So they have a large portfolio of different domains, so material science, biology, manufacturing, physics, nuclear, and so on. And the idea is, try to automate as much as possible some of the labs and do the connections through messages, layers, or common interfaces. So this is one idea. They are mostly working on the edge to HPC side, so how we connect to the edge. And we at the facility, we got to the point and said, okay, well, how we access our systems today? If you come to HPC system, the way normally you access, you do an SSH, you get to a login node, and then you're going to start deploying your tools and do all your analysis to happen. Some provide Jupyter notebooks. They are nice, but it's still, you have to be connected to the machine at some level. So Larry also mentioned about Super Facility API. TAC has TAPIS. Firecrest, there are others. Each center, they have different approaches for APIs. And of course, we would like to have our own, because everybody is developing their own thing. Even though I can always go to another API and say, yeah, yours is nice, but you cannot do this specific thing, so that's why I need to develop my own. But anyway, we are developing another API that is on how we can expose the resources from the facility. And Oak Ridge, for being on the moderate side, it has a lot of complexities about security and connections. So we are having all we are developing here, and as you see on this image, it's connecting to a test bed. We are not doing it to production right now, because production then it's another security level and an entire discussion that we have to go through. But the idea is how we can expose things like as the compute or your streaming data, or if you have a workflow, how you can orchestrate the entire workflow inside the system. And the idea is not only to access Frontier, but be able to access all resources connected to OLCF in this case. So we spent a lot of time working on that. It's based on Kubernetes. And we call this a service mesh because we take the service mesh approach that we use the Istio one to leverage these resources so we can better expose and have better control of the security aspects and how we do fine-grained authorizations for people to use. So it's still it's under development. If you have an OLCF account, you can contact us. You can start using that, to start playing with, and hopefully someday we're gonna get into production. So going one more level down, so we have the API. We can access the systems, but we said, okay, but we cannot be playing with Frontier, because Frontier is a production system, and we don't want to break down things there. So we need to be exploring new technologies. I'm part at OLCF that it's not on the systems operation side. I'm on a section that is more focused into the research and development aspect. So we are looking forward. So while systems operations is looking in how we keep Frontier, running and the users happy, we are looking into the next machine. So that it's, if you don't know the name, it will be Discovery. And somehow there is a joke, people keep saying since Jaguar, that somehow OLCF is amazed to name machines there is always a car with the same name, but just a coincidence. So what we did is we have a test bed that it's connected to IRI. So if you're part of IRI, the IRI is building an entire test bed that YesNet is enabling through the YesNet connectivity. And we have one that we call ACE, so the Advanced Computing Ecosystem. And the idea here is really to how we can explore new technologies that it's beyond of what we have in our systems. So we, of course, we got this cluster that we call Defiant, that actually is the early access Frontier machine that we renamed, and we prepared to be one of the clusters that has very similar to what Frontier has today. And then we started having other technologies like ARM64 with Wombat, graph cores, NVIDIA H100s on the processing side. On the data side, we have DAOs, VAST, Lustre, of course, and we provide the Globus. We are exploring the data streaming solutions that we are developing now that we call data streaming nodes, that we have the data transfer nodes, the DTNs. So now we want to have a DSNs, the data stream nodes, to accelerate these near real-time executions. And of course, how we have an OpenShift cluster on the side to be able to run the services that will be available. So thinking about all the workflow services and so on. We are also working closely with Intersect to try to connect their use cases. And through the S3M API that is not on this figure, so this is outdated, the idea is we connect with all of these different facilities and can be working with them and exploring next level technologies. So I talked to you, we look into the next level of things where we are going. And when we talk about all these technologies, these are nice, we can explore a lot of things, but I'm here to talk about workflows because this is my area and how we're going to solve these things. But I have to tell this story so you can understand where workflows are coming from. So basically, what we did was, okay, we had the procurement phase for discovery. So it was OLCF 6 machine. They're still undergoing. And when we put there is always, the benchmarks that we run. The regular benchmarks are HPL, mixed precision, and so on. That everybody that is involved in that knows them very well. But we keep saying workflows is the next applications. Things are changing. We need to evolve. So how we can prepare our machines to have, to be ready to run this kind of workflows. So we developed a small workflow benchmark that does end-to-end processing. And the idea here is, even though the main code of the workflow itself is an ML application that is doing some machine learning, training of neural networks, and so on, a small LLM, cool, that's nice. That's not the main goal that we are interested here. Because these, like you can get an ML AI benchmark or ML perf run and get some interesting results. But the point is, when you start having this connection, this ecosystem, how the new machine or discovery is going to behave inside this ecosystem. So we we added aspects of, well, we would need to have something that is going to have to handle streams of data. So that might be coming from, as you mentioned, several different sources. So that's the idea. So you have different data stream producers with different rates of the data production and size. Then you do, on this side, close to the machine, you have these clusters, service clusters that can be an OpenShift cluster or whatever service that is running. Then we hail these streams. We do the regular, ML AI workflows, very couple-tided here. There is some checkpoint in the storage. What we are looking is, since we are producing a lot of small data and having transferred around of this data, can we explore things like in-memory processing, like RDMAs and so on? So that's, and then at the end, while this is computing, we are always, feeding some streams to some consumers. That is also, they have different rates of consumption. So that's the one first idea, that is the workflow that was for the RFP. And the vendors had fun with that. And we have a lot of fun answering the questions about this. But personally, I don't think this is enough. This was just, as one small set, one typical application. So something else that we are working right now, it's called WF Bench. Actually, was my previous PhD student. Did this in 2022 and during her PhD thesis, and now we are evolving. And the idea is how we can create a suite of benchmarks that can represent different things, not only that simple application, that we wanted to have HPC and AI integrated workflows. We want to make sure that data management is involved. We want to take care of HPC, cloud, edge, and maybe quantum. I don't know. I'm not a quantum expert here, so please don't kill me on that. But maybe, so how we can do these hybrid QC HPC workflows and streams, if time sensitive, and everything is about energy. Well, might change with the government, but if you're still looking at energy efficiency, how we can evaluate these workflows and energy efficiency. So just to give an idea, the interesting thing about workflows, these are high throughput HPC workflows. They are computing exactly the same amount of work. They handle the same amount of data, but just because of the shape of the workflow, like the graph, you have completely different behaviors of the analysis. And something that is more interesting is this one that we did a very simple runtime analysis, overhead analysis on Summit. So it's not Frontier. We are doing the same now Frontier. We generated a workflow that had 100,000 tasks, and the workflow would do nothing. No computing, no I/O, no memory, nothing. It would just get to the node, start and die, and move to the next text. And then we analyzed the overhead of the workflow systems to see how long they would take just to orchestrate the 100,000 tasks. And I'm not going to tell which workflow system is here. You can read on the paper if you want, but it's a very optimized workflow system for HPC system. And just to orchestrate 100,000 tasks, it took about 2 hours. So 2 hours of Summit being allocated to do nothing. So it's another thing that we have to evaluate is it's nice to create these workflows that are becoming more complex, but we need to improve and understand how we can leverage the systems to make that. And what the opportunity we are having with the new OLCF machine is that before, we as a workflow developers or workflow system developers would come to a machine and say what is available, and let's play with that and try to do any hack that we can to make it efficient. Now we have an opportunity to talk to the vendors and say how you can improve things so we can improve that and not have this kind of situations anymore. So, of course, I'm not a quantum expert, but I just want to say another thing we are doing right now is we are working into quantum hybrid QC HPC workflows. So how we can manage that, we are developing a framework. On this paper, we have just a basic introduction of the framework. We're just working on another paper now that has the entire architecture of the framework in more detail. But basically, it's how you can have, part of the regular system, the classical system, so it's in blue here, connecting hybrid with the quantum systems. So in this case, we are not only considering the actual quantum hardware, but also the quantum simulators. So the idea is we are developing a framework that is going to be doing this management, a little bit of what you're saying, that how we can have a scheduler that will be more efficient to understand the different resources that are available. And if we could go more fine-grained, get the quantum resource, get the AI accelerators that might be available, get the HPC system. They might be running in a synchronized way or unsynchronized. It depends on how you define your workflow. But we are seeing some needs for that, and we are working on some actual real applications. I'm getting short on time, so of course, after we did that, we come up with some predictions. So what's going to happen on the workflows in the future? We had this paper early last year that we tried to touch into 5 different areas. Of course, convergence of AI HPC workflows, they have to converge because everything is AI now. So we have to, put AI there. But they have the AI workflows that have a completely different need. It's a different shape of the workloads. And we have to adapt our systems to this. Larry did a very good job talking about this. Energy efficiency, we have to because we know, we cannot be building larger and larger data centers. We are getting to the limit. So how we can improve our codes to, with the same power, do more or consuming less. Near real time data integration, don't want to touch this again. Cross-facility workflows. So this is all about, these workflows that have different instruments, different facilities, experiments, how we're going to connect all of this together. And we need to navigate the performance variability of different heterogeneous resources, because this is a reality. We are here. As a center, we need to look, of course, we're still leadership computing, but we start to need to look and say how we can build an ecosystem that it's not only one homogeneous machine, but it's connected to an entire set of different resources. And then funny, after that, what we do is we bring the community together, we talk. There is something called Workflows Community Initiative that I founded that 2-3 years ago. So every year we meet, it's virtual. We're gonna try to do it the first in person. We come up with a report, we discuss these issues and propose ideas. And what I do with the other people in the community, we share with every single program manager that we know this information and say, hey, if you think you want to fund anything related to workflows, you want to understand the challenges related to workflows, take a look at this report because this is what the community is saying. So we're getting there. And surprisingly or not, we got attribute technology predictions. I got invited this year to work with Deon, so I was very excited about that. And we had one that is, even though there is not in the title workflows, it's AI optimized green HPC, but it's all about how we do these AI HPC workflows optimized for energy efficiency. So I strongly recommend you look at the report. Actually, there is one recommendation that is on smart agriculture. So it was nice because I was trying to understand the difference between smart AG and digital AG. I couldn't really, I didn't have information on that. And there is another one that I never heard before, so probably you heard, that is talk about space computing, whatever this means. So, it's an interesting report, so take a look there. And just to finalize, I like to come up with this graph. It's not a comprehensive graph, but it tries to keep a little bit of everything that we are doing and how we see. So if you're doing autonomy size, we want to achieve that. We have the resources, networks, instruments, test beds, so on. Then we have, to around that build how we have access to it in federated ways with APIs, policies, federated identity authorization. Then it comes almost everything that we are doing at Oak Ridge. Benchmarks, because we need to understand how these things work and how we can improve. We need to have interagency collaboration. We need to stop, saying that, oh, I'm DOE, I'm not talking to NSF or NIH or DARPA or so on, or, inter-countries, inter-nations collaboration. We need to work together on these things. So that's the only way we can automate. Distributed service to orchestrate, of course. Threaded learning, fair workflows components. I didn't talk too much about fair, but there is fair data. We need to look at fair workflows. So how we can reproduce these workflows. Provenance and metadata. So if you're doing AI today, it's amazing to get to the result, but you need to understand how you get there. And high performance data management, that somehow I think that community has put this on the side. And we need to bring this discussion back to the AI community. And then my belief is once we have most of it, or, it's not comprehensive again, then we can get, train the users, train the workforce, and have better scientific results. So with that, I'd like to thank you. And if you have questions, happy to answer.
Thank you very much.
Okay.